Here is the next question, number 31. The RMS value of the periodic waveform given is, so we have our four options, 2 root 6, 6 root 2, root of 4 by 3 and 1.5. Now what we have to remember is that the RMS of the waveform is equal to the RMS of one period of the function. So here we will have to just take a note of the period from 0 to t. This is one period, one cycle of the waveform. So to find the RMS value of the entire waveform, we can just find out what is the RMS value of one period. That would be the same as the RMS value of the entire waveform. Okay, so you will have to note the basic formula for the RMS of any waveform. So let's write that down. The RMS value for any waveform is 1 by t 0 to t f square of t dt whole under root. I hope that is clear. So this is the RMS value for any waveform. We will have to first here find out the function f of t. Now we have the entire time period as 0 to t. So 0 to t and 1 by t is the same for this problem. But we now have to find out the function of f of t. Now in order to do that, we have to look at this waveform. Now from 0 to t by 2, we have a linear line, correct? And from t by 2 to t, we have a straight line at 6. So from t by 2 to t, we have a constant value of 6. But from 0 to t by 2, we have a linear line. Now because we have this slope here, we have to go back to our basic about writing down the equation of a straight line and then solve. So let me just grab another sheet of paper and we'll begin. Okay, now let me first write down the same formula. Formula for RMS value, which is 1 by t root of 0 to t f square of t dt. Okay, now let's take a closer look at the diagram, the waveform given. So first we have a slope here and then a constant here. Now this point is our origin 0. Here we have, this is minus 6, this is positive 6, and here this is t by 2 and t. Now consider just from 0 to t by 2 portion, this portion here. If this is the origin, so we know the point here 0, 0. Now what is the point over here? At this point it is t by 2, minus 6, right? Okay. Now using this, we are going to find out the slope of this line. So that is our next step. Let's find out the slope. Do you remember the formula of the slope? M is equal to y2 minus y1 divided by x2 minus x1. Now let's substitute the values over here. What is y2? Consider this to be a point x2, y2, and this is x1, y1. So here we would have minus 6 minus 0 divided by t by 2 minus 0. And that gives us a value of minus 12 by t. So here the slope m is minus 12 by t. Now what is the equation of a straight line? Equation of a straight line is given by y is equal to mx plus b or c. Now here, because the line passes through the origin, b is anyway 0. So we'd have y is equal to mx. So m is minus 12 by t, and what is x? X is t, because here the axis is t-axis. It is time domain. So here the equation of the circle in our problem, we will consider it to be y is equal to let me just, yeah, okay. So y is equal to n is minus 12 by t into t. Or we can just simply write this as minus 12t by t. So this is going to be the equation for our slope here from 0 to t by 2. And from t by 2 to t, the function is a constant, which is 6, because it is a straight line. Okay, let me just grab another sheet of paper and we'll write it down. So now our RMS value is 1 by t will remain the same from, we are going to split the integral into two parts. Okay, so first we will write down 0 to t by 2. And what is the function of 0 to t by 2? Minus 12t by capital T square dt, because it is f square of t, right? So this is our first part of the function. Next, plus integral t by 2 to t, that is the next thing. And we have our constant of 6. So that's 6 square dt. And the whole thing is under root. Right. There. Okay. Now let's solve this. So first, let's take care of the parts over here. Now what will we have here? We'll have 1 by t integral 0 to t by 2. That's 144 t square by capital T square dt, plus integral t by 2 to t 36 dt. And right, okay. Next. Okay, next, let's solve this further. So if we take 1 by t inside, we will now have 0 to t by 2, 144 t square by capital T cube dt, plus, let's take the constant outside for this part, t by 2 to t, 1 by t dt. The whole thing to the power of 1 by 2. Anyway, here t is also a constant. We can actually bring that out over here. Anyway, so now for the next step, let me just squeeze that in here. Let's integrate. Now when we integrate, what do we get? We will have 144 by t cube times t cube by 3 at 0 to t by 2, plus 36 by t from t by 2 to t. I hope this makes sense. 144 by t cube is the constant here. Integral of t square is t cube by 3 at the limits of 0 to t by 2. And then plus we have 36 by t as the constant. Integral of 1 is t at t by 2 to t. So this is our statement. Now let's solve this further by applying the limits. Okay, so we will now have 144 by 3 times 8 plus 32 by 2 under root. So what we have in the previous step over here, we just substitute and then t's cancel out really. So I'll leave that step to you. You can, I'll let you work on that. Here we have 144 by 3 times 8 plus 32 by 2. When we solve that further, we will have 6 plus 18, which further comes to 24, root of 24, and that gives us a value of 2 root 6 amps. So in this case, our final answer is 2 root 6. And let's see which option that matches with 2 root 6 matches with option A. Well, this is the final answer, and I hope the explanation has helped.